Before I go through this question, please just pause the video and reread the question. Okay, so as I'm reading the question, I would be drawing some pictures and making some notes. And here's my helicopter that my parachutist is falling out of. Here's my parachutist modelled as a particle. And that helicopter is 550 metres above ground. It says falls vertically from rest, so U is equal to 0. Parachutist falls for 3 seconds before the parachute opens, so T equals 3. While she's falling, before the parachute opens, she's free falling under gravity, so A is 9.8 meters per second squared. But then they tell us we want gravity modelled as 10 meters per second squared, so we don't use that. We're going to use what they're asking us to use there, 10 meters per second squared. And then we want the speed when the parachute opens. So we've got U, T, A, and we want V. The equation that links those is V equals U plus AT. So V equals 0 plus 10 times 3. So V is 30 meters per second. That's the velocity. We're asked for the speed, so this just write speed is 30 meters per second. So again, for question for part B, just pause the video to read that information and then start up again. So we're looking for a speed time graph of the journey. And first thing, when she left the helicopter, her speed was 0 because she was at rest. So I know that I'm going to start down here. So speed and time. Then for the first 3 seconds, she fell at 10 meters per second. So 1, 2, 3. The first 3 seconds, let's say 10, 20, 30. She fell at 10 meters per second. So my first section of the graph would look like that. After the parachute opens, immediately decelerates at 12 meters per second squared for 2 seconds. So her velocity changes by 12 meters per second. It decreases by 12 meters per second for every second. So 4, 5, we're up to here, and we were at 30 meters per second. Over the next second, we come down to 18. So that's going to be about there. And then we do another 12, drop by 12, and we'll come down to about 6. So at 5, that would be 6 there. She then reaches this constant speed here, which is 6 meters per second, and she continues until she reaches the ground at that constant speed. The total time taken is T seconds. And there is our